Hello guys, welcome to ruling-academy.com. This video is part 2 of the series Surface BOP Control System. It's about the control for annular BOP and diverter system. Similar to part 1, in part 2 we'll learn about how the operating system works from the moment a button is pressed at a remote control panel to how fluid flows through the process and light bulbs are lit up. Again, this is the classic diagram that many people use to explain you how things work, but I'm not going to use them because this diagram is too messy, too busy to me. This is big no. I'll reorganize this diagram to make sure that it's clearer and easier for you to understand. This is how I reorganize it. Number one, in part 1, we have discussed the way the manifold works and supplies power. Light bulbs are lit up on the manifold for the RAM BOPs and the choke and the kill HDR valves. If you want to visit it, visit my website here or my YouTube channel here for more information here. All right. Now, before we go in forward, I need to emphasize that this very diagram you're looking at is an example configuration on a tender rig. All right. Tender rig is different from jacket rig on how things work. Number one here, annular and the diverter, they are sharing the same control. Because on tender rig, we use annular diverter packer. We don't use KFDJ insert packer. Therefore, annular diverter packer can be shared control with annular BOP. All right, there is one remote control, one remote and manual regulator to control the pressure in the line for this annular BOP. All right, when you press increase, pressure in the line is increased, and when you press decrease, pressure in the line is decreased. And then you have one separate line, manifold, diverter manifold, to supply the hydraulic fluid to annular flooding valve, port overbore valve, and starboard overbore valve. All right, so now this is the difference, right? You have one manual regulator. We set in a range 500 to 1,500 psi. When we say manual, you can't control it remotely from remote control panel. You have to come down to the cooling unit and the local control panel for a diverter to control it. Okay, so annular flooding valve and these overbore valves are hydraulically operated and controlled, different from the jacket rig. And for the overshot, you have another manual regulator. It regulates the fluid from 3,000 psi down to 1,500 psi here and supplies power fluid to overshot packer. This is also different from the jacket rig. Now this schematic now you're looking at now is for the jacket rig. You also okay, on jacket rig and tender rig, the way it works is the same for the manifold. All right, but now for the annular BOP, we have one separate line to control the annular BOP. Of course, you have increase and decrease button to control this line here with the air-operated hydraulic regulator, which means you can remotely control the pressure in the line from any remote control panel, or you can come down to the cooling unit to press the increase to increase pressure in the line and press decrease to decrease the pressure in the line. And of course, you also have one separate line here to supply power fluid to the manifold, to the diverter. We call it diverter manifold. Okay, this line here, right? Okay, in this line here, you have three smaller branches. First is to supply the power to diverter insert packer itself. There is one remote and manual regulator, all right, in the range from 0 to 1,400 psi here, this one here. All right, you can remotely adjust the pressure in the line from any remote control panel. All right, it supplies power fluid to the diverter insert packer. And then you have one more line here, this line here, goes through a manual regulator, which is set in the range 1,200 to 3,000 psi. Usually we set at 1,500 or 1,700 psi. It supplies fluid to the insert lockdown, the diverter insert lockdown doors, right? KFDJ system, you have lockdown doors. And you have one more line here, right, to supply the power fluid to the overshot packer and the flow line sieve. It is set usually 250 or 300 psi. All right, and this is also manual regulators. So these two manual regulators here, you can't control them from any remote control panels. You have to come down to the CUMI unit where you have the local diverter control panel, and you adjust the pressure reading in there. And for all the other valves of the diverter system, for example, annular flooding valve, flow line valve, trip tank fill-up valve, port overbore valve, starboard overbore valves, and the diverter test line valve, they are all air operated. So this is the major difference. In this video, we will examine only the control system for on a tender rig for annular and diverter system because it doesn't take a lot of time. All right. So this is the screen of a remote control panel. We have the master button here, which we need to depress it all the time if we want to activate any function on annular BOP or diverter from the remote control panel here. At the moment the BOP, annular BOP is open, green light is on. So when we press close, we expect green light to be off, the red light start blinking, flow light start running, the gauges on accumulator and annular will drop, the pressure gauge drop, and then they come back up. See, now they come back up. Nothing happens to the manifold pressure gauge. And finally, the red light is on and the flow meter stops running. Now we will look at the hydraulic schematic to see exactly what are happening behind the scene and driving all these phenomena. Now this is complicated. This hydraulic circuit is complicated here. All right. First, we examine the control for the air operated hydraulic regulator, which allows us to adjust the pressure in the line for the annular and diverter packer to increase and decrease. Okay, this is a 3/4 control valve. It is air piloted, and this one is also air operated. All right. But on this part here, to control open and close the annular BOP, they use the same kind of valve, 3/4 control valve. It is also air piloted, but it is hydraulically operated. Okay. So now we come back to the regulator. All right. And when there is no more air acting on either side of the valves, all right, meaning when we don't press any button, increase or decrease, all right, we don't supply any pilot air to these control valves here. The valve sleeve is returned automatically to the middle position, all right. And when we press increase, what does it do? What do we do? We send a pilot air to activate on this side, on the increase side. It pulls the valve sleeve to the increase side, and the supply air is routed through this port and comes out, sent to the air-operated hydraulic regulator. It regulates this here is 3000 psi. This line here, it takes 3000 psi fluid, supplies into it, and regulates this 3000 down to your desired value, and send this regulated pressure power fluid to the SPM valves here to activate the function open or close annular BOP. So upon releasing the increase button, when we release it, we stop supplying air, pilot air, so the valve is returned to the middle position. Okay, no more air is sent to the air-operated hydraulic regulator anymore. Okay, so the power fluid stays in the line the same. It is fed to these two SPM valves. These two SPM valves, one is for open and one is for close, right? They are cross-circuited and cross-piloted. All right, so now let's look at this one. At this position, the last time we opened the annular BOP, so the last time the power fluid, the regulated power fluid, is sent to these two valves. These two valves here, last time, all right, they stay at the last position they are activated. These two valves are hydraulically piloted. Now look at this line here, this yellow line here, and this yellow line here. they are routed back to this control valves to control the function open or close, right? So this control valve here takes 3000 psi fluid into it, all right? At the middle position, it takes the fluid here and it blocks it off, doesn't send anywhere. On the output here, you have this closed line and this open line. They are joined together in the middle here internally and vented to the tank. So there is no fluid sent, no pilot fluid sent to activate these two SPM valves here. So therefore, these two SPM valves remain at their last position. This is their last position. On this last position, on this open SPM valve, it routes, it allows regulated fluid, which is the brown line here, goes through it, feeds through the line, open chamber of the operating piston. There is a pressure sensor on this line. It is set at 250 psi. It senses this pressure in the line and it sends the electric signal to the remote control panels to light up the pumps open. All right, so that's the reason you see the annular is open, even though now you don't press any button, right? The control valve is at the middle position, no pilot, right? No pilot fluid is sent out to the valve, but the pressure in the line is of the open line is remain in the line. So that's how it works. All right, so when we come back to this control valve here, if we press close, all right, what do? We send a pilot air to act on this side, the closed side of this control valves. It will move the valve sleeve from the middle position to the closed position, this position here. At this position, the internal pulse will route the 3000 psi through this line here. Follow this line here, the red line. All right, it will join into this closed line here, right? It will join here. This open line here will join to this port here, all right? Will join here, all right, and will be vented to the tank. So the 3000 psi will be joined over here, and it will power up here. It will pressurize up this line. This line here is split into two parts. One is acting on this SPM valve, closed valve here. It will pull the sleeve of this SPM valve to this new position. And another line here, split out here, come down here and go and acts on this side, the opposite side of the opening SPM valve. It will pull the sleeve of this SPM valve, the open valve, to this position. All right. When now look at this open valve here, SPM valve. When the valve sleeve is at this position, it takes the fluid in this brown line, which is being connected to the opening chamber, and it routes the fluid to the tank, vent the fluid to the tank. So this pressure switch doesn't send any more pressure in the line. So it will not stop sending electric signal to the open pump. That's why the open pump will be off. On this closed SPM valve here, when this 3000 psi pilot fluid acts on this side of the closed valve, it pulls this valve sleeve to this position. And this position, it will connect this regulated power fluid to this port, comes out and pressurize up this line here. Okay, this pressure sensor here will sense the pressure in the line and will send the electric signal to light up the closed pump. At the same time, it will push, the pressure will feed into the closing chamber and push the piston up to close. And we will see the flow meter running. All right. We see the pressure gauge on the accumulator pressure gauge drop. The annular pressure gauge also drop. We will see the air pumps, which are the primary pumps, to kick in first. All right. But if the pressure in the accumulator pressure drops down to 10%, drop down 10%, these three pumps will kick in. If the pressure on the accumulator continues to drop to 85%, right, then the secondary pump, which is the electric pump in this example, will kick in. They will all kick in, running, and charge up the system, and we will see the accumulator pressure gauge and the annular pressure gauge come back up. And finally, we will see the flow meter stops running. So that's how things happen. Okay, we will examine it. First, we press increase. It's already increased. Now we press decrease. Pellet air is action here. All right, air comes here to the air operated hydraulic regulator. Pressure gauge on the accumulator on the annular drops. We release the decrease button. All right, the valve sleeves return to the middle. All right, see that? And now when we press close to close the annular BOP, now look carefully. Air pellet acts on this side, pull the air sleeve, valve sleeve, and 3000 psi comes down here. This line is changed from yellow to red. See that? It acts on here. And now this line here is changed. All right, it pushes. This line is vented. All right, see the flow meter is running. The pump's running. Okay, charging the system up. The pressure gauge come back up. All right, and finally the flow meter stopped running. So that's how the whole things happen. All right, I hope you get a very clear picture of how things happen. Now, next, what happened when we release the close button? All right, we release it. All right, when we release the close button, no more air supply to this side. The valve is returned to the middle position. All right, so these two output line here, all right, this closed line and open line, they are joined internally and vented to the tank. All right, so there is no pilot fluid acting on these two SPM valves. These two SPM valves, this one open and this one valve closed, remain at their last position. At their last position in here, this line, this power fluid, regulated power fluid here is routed through the closed line here. It still has pressure in it. All right. So that's why the pressure switch here, which is set at 250 psi, still senses the pressure in the line, and it keeps sending the electric signal to light up the closed pop. That's why we still see the closed pop is on. All right. That's what happened when we release the close button. All right, now next we come to the diverter manifold. The diverter manifold, as we said before, on a tender rig, it supplies power fluid to annular flooding valve, port, and starboard overbore valves. We will first examine the port and overbore starboard valves, overbore valves, because they work the same way. They use the same equipment, all right? And now, because they are the same, so we will review the starboard overbore valve. We will examine it. All right. For starboard and port overbore valves, they don't use pressure switch. They use proximity switch to detect the valve position. All right. So there is one regulator. This is manual, right? You can't control it from any remote control panel. You have to come down to the local diverter control panel to adjust it to whatever the value you like, in the range 500 to 1500 psi. All right, so this is the regulator here, and it supplies fluid down here. Now this valve here are also 3-4 control valves, air piloted, hydraulically operated. So when you don't press any button or when you release the button, the valve will be you stop sending the air to the valves, the pilot air to the valves, so the valve sleeve will move to the middle position. This is the middle position. At the middle position, what does it do? It blocks off the supply, and it will join one output and one input in here, the return line in the join together and vent them to the tank. So there is no pressure in the lines here. All right, on the downstream the valve, there is no pressure. So this is the difference. But the valve position is indicated by the proximity sensor. So the last time, for example, in this case, this starboard valve was closed. All right, and then we release the close button. So when it was closed, when we press close in here before last time, the valve was closed, so the closed proximity switch senses the valve at this closed position. It sends signal to light up the closed pop. Okay. So what will happen when we press open this button? We will send pilot air to act on this side. of the valve sleeve will be moved from middle position to this position. And this position, this power supply, this fluid will be drawn to this port. It comes out to the open line, go here. So this line will be pressurized up, right? Here it will comes down here, pressurized up here. This line, okay, is the return line. It will be vented to the tank, all right? The valve will move here. What do we see? We see accumulator pressure drops, sure. Annular diverter, no, because we're not acting that, and we don't activate anything in it. Manifold pressure, nothing. But the diverter manifold pressure will see pressure drops, and flow meter will run, all right? And then when we release the open button, well, we come to that part later. Now let's just examine what happened when we press open button first. When we press open, okay, and the flow meter start running, the valve sleeve moves here, you see that one? All right, this close light is off, the green light start coming on soon upon the arrival of the valve to the open position again. The proximity sensor here senses the position of the valve and it sends electric signal to keep this light on. Did you just see the pumps running and charge the pressure on this gauge? And this gauge up. See that? One more time, we press, and of course the valve handle moves from the middle position to the open position. All right. And what happened when we press release? All right. At the moment the valve is open, right? When we release it, we stop supplying air. The valve is returned to the middle position. And see this line here is changed from pressurized to vent. But the valve position doesn't change. Therefore, the open proximity sensor still senses the valve here and it sends signal to keep this light bulb open on. Okay? So that's how it works on the starboard and the port overboard valves. All right. Now it works the same way for close. See, close, when we press close, the same thing happens, right? See, this case, the diverter manifold will drop, accumulator pressure will drop, right? See this one. I see now power fluid flow here. Follow me here. Power fluid from here comes down here, go out here. This line here is vented back to the tank here. See that? And while now the valve is closed, the pressure, the proximity sensor here and the closed position senses the valve position. It sends an electric signal to light up the light bulb close. Okay. So now what happened when we release the close button? Okay, nothing. Okay, we release it. We stop the air supply. The valve is returned to the middle position. Okay, and the lines are vented here. Okay, but the light bulb is still on. Right? See that? All right, that's easy, isn't it? Now we come to the annular flooding valve on the tender rig. On the tender rig, the annular flooding valve is hydraulically controlled. All right, and its position is indicated by the pressure switch, not by the proximity sensor switch anymore. All right, so there are two pressure sensors on the closed line and the open line. All right, and they are both set at 200 psi, 250 psi. All right, so now they use the same control valves as the overboard valves, right? Also automatically return to middle with when there is no pilot air acting. All right, but you don't know whether the valve is open or closed when you release the button, because the valve is returned to the middle position, and at the middle position, the lines here, the open line and closed line, they are both shown and vented to the tank. So this annular valve, flooding valve here, it is, you can line it up at any position in the line. It is either fully closed or fully open, or partially closed or partially open. Now let's see, when you press open, you supply pellet air here. The power fluid is routed to this port here. All right, it pulls the valve back down, and there is pressure in the line. This pressure sensor senses the pressure in the line. It sends the pressure, the signal to light up the pump in here. Okay, flow meter runs. Do you see the pumps run and charge up the accumulator pressure and diverter pressure gauges? All right, and when you release the button open, all right, so now when you release the button open, you stop the pilot air, the valve is returned to the middle here. Okay, and the valve handle is also returned to middle. Okay, but the valve remains, the valve itself is remain at the last position. The last position, what is the last position? You know it is open, but you can't tell because on the remote control panel it doesn't show you. So this is a disadvantage here. All right, I need to fix it. All right. The same thing when you press close. All right, you activate on this side with the pilot air. All right, see this pressure gauge and this pressure gauge here, accumulator and diverter manifold both drop. All right, and then they come back up because these primary pumps just run and charge the system up. The pressure in the line senses the pressure in the line, and the pressure sensor switch senses the pressure in the line and sends the electric signal to light up the bulb close. So you have to keep it depressed all the time. To keep the button depressed all the time. Okay, but the moment you release the button, okay, you release the close button, you stop supply in the air, then the valve is returned to the last position, and they vent the pressure in the line, and the light bulbs are off, and you don't know, right? So this is how it works on the tender rig. All right, and now for the overshot breaker. The overshot breaker, same. You have a manual regulator here. Regulate it down to 1,500 psi and send the power fluid to the overshot breaker. And the way the overshot breaker works is similar to the annular flooding valve here. All right. When you press vent, all right, you pull the valve sleeve, you send the air pellet, all right, to activate on one side. You pull the valve sleeve to the vent side, and the pressure is supplied from the input out to the vent. Pull the valves back here, pull the piston back, okay, and the pressure on the light bulb on vent is on. All right, the valve handle moves the vent, right? But when you release the vent button, you have to keep it vent on pressing vent, and when you release vent, you stop supplying pellet air, and the valve sleeves move back to the middle position. And then there is no more indicator, no more indication. The light bulb is out, it's off, okay? Because there is no more pressure in these two lines here. These two lines are joined together and vented to the tank here. See that? So you don't know, right? You don't know how. So this is also not very clear on the indicator side, right? And when you press pressure, the same thing happen, right? The same thing happen when you press pressure. You supply pellet air on this side, you pull the valve sleeve here, and the power fluid is sent to this port, comes down, push the piston, and this pressure sensor switch here will send, it senses the pressure in the line, it sends signal to light up the bulb. Did you just see the diverter manifold pressure gauge and accumulator pressure gauge drop? The pumps run, charge system up, and they came back up. Oh, sorry, the flow meter didn't run. Now the flow meter runs. Okay, it's just a glitch. All right, and what happened when we release the button pressure? When we release pressure button, all right, we stop supplying pellet air, and the valve is returned to the middle position. And the output lines here and this return line, they are joined together and vented to the tank. The valve handle moves back to the middle position here. All right, guys, I think that's the end of this part 2, the control for annular BOP and annular diverter packer on the tender rig. I'll make another video to explain how the control system works on the diverter system, KFDJ system for jackup rig later. And see you soon in that video. Thank you and bye-bye.